Hi algebra students, please find your 8.2 notes template. In 8.1 we talked about looking at a linear equation and making a table of values, finding some ordered pairs, usually 3, and plotting the graph from that. 8.2 is all about finding the intercepts of a graph. And what an intercept is basically if you have a line. So I'm just going to sketch one in here. You don't have to add it to your notes. The intercepts are where it hits the x-axis, so that's the x-intercept, and we abbreviate x-int, and where it hits the y-axis. So the y-intercept would be right about there, and we would call that the y-intercept. Now what you need to know about intercepts is they are the ordered pairs of the points where the other coordinate is 0. So if you look at your x-intercept that I just drew right here, this looks to be about, let's say, 2.25 comma 0 because I didn't draw a nice point. But you'll notice that the y coordinate is 0 at the x-intercept. So the x is a number and the y is 0. Same thing if you look over here, and this one was actually a better point that I drew here. This y-intercept looks to be about 0, 4. So at that point, the x is 0, whereas the y is actually a number. So we're going to look at how you can actually find those things. So let's take a look at example 1. We have the linear equation 3x plus 5y equals negative 15. And I have a workspace that's divided in two. I want to find the x-intercept and the y-intercept. And there's a basic process for both. Basically, for the x-intercept, you're going to plug in y equals 0 and solve for x. So what I want to do is take that equation, plug in 0 for y, so 5 times 0 equals negative 15, and then I'm going to solve for x. So go ahead and do that. So I plugged in y is 0, which means essentially anything that's being added to this 3x disappears. So we got 3x plus 0, which I took away the 0 in the next line. Dividing by the coefficient in front of x, we find that x is negative 5. This represents an ordered pair. Negative 5 for x and 0, which is what we plugged in for y. Now we're going to do the same kind of process over here for y-intercept, but this time we're going to make x equal to 0, and we're going to solve for y. So I'm finding that when I plug in 0 for x, y is equal to negative 3. And this also represents an ordered pair. This represents 0, because that's what we plugged in for x, comma negative 3, because that's what we got for y. So what we're going to do is we're going to go ahead and go down to the graph, and we're going to plot those 2 points. Negative 5, 0 would fall on the x-axis, 5 to the left, and 0, negative 3 would fall on the y-axis, down 3. And when I connect those points, I'm going to get a line that is the graph of all the solutions of the linear equation 3x plus 5y equals negative 15, but it's kind of nice because we only needed 2 to find the graph. Let's try the same process with example 2, which is 2x minus 6y equals 12. The only thing I want to caution you about is this negative sign, this minus sign, is going to turn into a negative. So just be cautious about that when you're plugging in 0 for x, because if we skip over to the y-intercept, we've got 2 times 0 minus 6y equals 12. This is going to turn into 0 minus 6y equals 12, which is negative 6y equals 12. So just be cautious about that as you're solving. Go ahead and find the x and the y-intercepts. So here are my two intercepts. I've got x to be 6, pardon me. So the ordered pair would be 6, 0, which is on the x-axis, 6 over to the right, and 0 for the y. And I've got 0, negative 2 as my y-intercept, so that is down 2. And then I'm going to plot those and connect them, and that is the graph of my line. In the next example, I'm going to have you combine what you know from 8.1, which was to make a chart, and from this section as well, because what I'm asking you to do is put the equation in function form. And that just means that you are going to get y alone on the left side. So the problem between having y alone on the left side and the equation in the form it is now is this piece. This 3x is holding you back from doing that. So my goal is to move it over to the right side. And in order to do that, I need to subtract it from both sides. So what that's going to look like is we're going to subtract 3x over here, and we're also going to subtract it over here. But you'll notice I'm not lining it up right underneath the negative 2 because that's a constant and I can't subtract a variable term, negative 3x, from a constant, negative 2. What that's going to give me is these are going to cancel out, which is what I want. I'm going to get 2y on the left side, which is one step closer to what I want. And then over here, I can't take this subtraction, so I'm just going to write these side by side. Now, I'm running out of room, so I'm going to go back up here. What I want to do next is I told you I wanted y alone on the left side, so it should be a y equals kind of equation. The thing that's holding me back from that now is the 2. So I'm just going to copy where I left off over on the left side. Now, how do I get rid of the 2? Well, they're cemented with multiplication, so I can undo that by dividing. But if I divide one piece of my equation by 2, I've got to divide all of them. And there are 3 pieces. The y on the left side, the constant on the right, and also this variable term, the x term, on the right. What that's going to do is I'm going to get y alone, which is what I wanted. Negative 2 divided by 2 gives me negative 1 minus 3 divided by 2 can't be simplified anymore unless you make it a mixed fraction. And you're going to learn later why you don't want to do that. So this is one of the reasons I've been telling you all year improper fractions are the way to go. Now the last thing I'm going to do, and this will make more sense for later, so you're just going to have to take my word on this one for now, is I don't like the order that these two things on the right side are in. So I'm going to use the commutative property, but I'm going to kind of have to pretend that this is plus negative 3/2 because we don't have commutative of subtraction. So the last step is we're going to make this y equals negative 3 over 2x plus negative 1. And that is in function form, which means y is alone on the left side. And what we're going to do now is we're going to copy that equation into the chart that's provided for us. So negative 3 over 2x plus negative 1. And we're going to use that equation to plug in some x values and find y values to graph it. Now, in our 8.1 lesson video, we talked about if there's a fraction coefficient in front of the x, you want to be very cautious with the x values that you're picking. Because this has a denominator of 2, I will be safe with picking values that are multiples of 2. So I'm going to stick with the 3 that I like best, negative 2, 0, and 2. Go ahead and plug those in and make sure that you can find the y values. So take a look at your chart and make sure that your y values match mine. And then we're going to go ahead and go to our graph and we're going to plot those points. So negative 2, 2 would be to the left 2 and up 2 and make a dot. 0, negative 1 would be down 1. And 2, negative 4 would be to the right 2 and down 4. And then we're going to connect. So the graph of my equation will look something like that. For our next example, I'm asking you to do the same thing you did in the last example. I want you to get the y alone. The first problem is this x. So I am going to move it by subtracting x from both sides. And I'm being very careful to write it to the side so I don't accidentally take 9 minus x. These cancel out. Just be cautious. This is a negative sign. Because there's no more subtraction, it drops down as a negative. We've got 9 minus, I'm going to add a 1 in front of that x. And then you know what? I'm going to go ahead and rewrite the subtraction and I'm going to put it over to the right where I have some more room to work. So I'm going to make it negative 3y equals 9 plus negative 1x. The next problem, the last problem that I have between me having y alone and not having y alone is this coefficient of negative 3. So I'm going to get rid of it by dividing each piece by negative 3. When I do that, I get y alone, which is what I wanted, 9 divided by negative 3, which is negative 3, plus, this is a negative 1 over a negative 3. While I can't divide those any further, I can make it a positive because we've got a negative over a negative. Now the last thing is you want to reverse this order by commutative. So I want y equals 1 over 3x plus negative 3. And we're going to fill that into the middle of our chart. Y equals 1 over 3x plus negative 3. Now this is one of those cases where you can get ugly y values if you're not careful plugging in. So take a look at the coefficient on the x, and I want you to tell me what kind of values you should plug in for x. So you should be determining that you need to use values that are multiples of 3. So I chose negative 3, 0, and 3. Go ahead and plug those in to find the y values. So looking at your chart, you should be getting the 3 ordered pairs, negative 3, negative 4, 0, negative 3, and 3, negative 2. And then below is my graph for that equation. Make sure that you bring any questions into your math teacher the next instructional day. And we will be practicing the skill of getting y alone on the left side of the equal sign.